Alright guys, today we are going to review simplifying square roots. This is something you should have learned in Algebra 1, but we're going to review it now because you're going to need this skill to work the problems in the next couple sections we're going to do in Algebra 2, and you will need it off and on throughout the rest of the course. So before we actually start simplifying square roots, we're going to talk about some perfect squares. Okay, so let me move this out of the way. This is the worksheet you got after your test. We'll come back to it. So now, as far as perfect squares, knowing what a perfect square is and being able to recognize some of them will help make simplifying square roots easier. So now, if we make our list, and I do 1 squared, I get 1. 2 squared, I get 4. 3 squared is 9, 4 squared, 16, 5 squared, 25, 6 squared is 36, 7 squared is 49, 8 squared, 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. Then we're going to add just a few more in another column over here. Not many, but these are the most common ones. And there's a couple of others you need to be familiar with. Okay, 16 squared, that is 256. 17 squared is 289. 18 squared and 19 squared, even as much as I deal with perfect squares, those are not two that easily come to mind, so they are not that common. So we're going to skip them and leave them off our list. Okay, so we're going to skip down and go to 20 squared is 400. 21 squared is 441. Again, we're going to skip 22 and 23 because they are not that common. 24 squared is 576. 25 squared is 625. Okay, these you should have learned at some point. I can remember, even as long as it's been, that back in middle school I had to memorize perfect squares. And it was a timed test. One day we had a timed written one, and it was oral. They would read the question, we would have to write the answer. It was not on the paper in front of us. There was no going back to it if you missed it. We did it that way one day where we wrote the answers on our paper. The next day, we sat with the teacher at her desk individually, and we could go through them in order, 1 squared all the way up to 25 squared. And then we had to do it again where she just skipped around and you could not pause between her question and your answer. If she said, what is 5 squared? You had to immediately say 25. If you paused, it was wrong. So I had to memorize these. And at some point, I also knew 18, 19, 22, and 23. But like I said, over the years, I don't use those often enough, so they're not that common, so I left them off of your list. You need to be familiar with at least these. Okay? So, back to our worksheet that you got after your test. And I don't really have enough room to work on that worksheet, so we're going to continue to work on notebook paper here. Okay, the very first question was the square root of 96, and they want us to simplify it. I'm going to give you 2 different methods for simplifying this. One of them involves perfect squares. What you want to do is you want to figure out, is there a perfect square that's a factor of 96? Well, how do you do that? What I would do is I would take my list of perfect squares here and start with any perfect square that's less than 96 to see if it's a factor. I can't do 96 divided by 81. I can't do 96 divided by 64 or 49 or 36 the first one I can actually use is 16. 96 is the same as 16 times 6. So I'm going to rewrite this. 16 times 6. Now, here is technically what you're going to do. This is what the rule says. You can now split that into separate radicals. And now, the square root of 16 is 4. You cannot take the square root of 6, so it stays inside, and that is your answer. Okay, as we do a couple more of these, I will probably skip this step where I write them out separately, but you can continue to do that if you need to. The other way to do the square root of 96 is to write it out as prime factors. Okay? And to write it as prime factors, you can do a factor tree, but I really don't like a factor tree. You can do it, it's fine. When I do a factor tree, I tend to lose parts of my information. So I do what's called a factor ladder, and here's how it works. I start out with 96, and I do this that looks like an upside down division. It's going to make a ladder in a minute. And I always start with 2. Will 2 go into 96? It does 48 times. And I keep dividing by 2 until I can't do it anymore. So now 2 goes into 48, 24. 2 goes into 24. Not 8, it goes 12 times. Let me fix that. Goes 12 times. 12 divided by 2 is 6. 6 divided by 2 is 3. Well, 3 is also a prime number. So your prime factors are here. Okay? If you multiply all of those numbers I just highlighted together, you get 96. So what I'm going to do here is rewrite 96 under my square root. I'm going to do 1, 2, 3, 4, 5 2's and a 3. Okay, all of that came from here. If you did a factor tree, these are all the numbers that are at the ends of the branches. Now that I have this written in factored form, now I've got to find pairs. Because this is a square root, I'm looking for pairs. Well, this is a pair of 2's. Well, 2 times 2 is 4. The square root of that is a 2. Here's another pair. So 2 times 2 is 4. The square root of that gives me another 2 on the outside. I can't pair this 2 up. I can't pair this 3 up. So those are going to stay inside. And now outside, 2 times 2 is 4. Inside, 2 times 3 is 6. Same answer that we got over here, different method. You can do whichever method you prefer. I like to do the perfect square method just because it's a little bit less work. And as long as you are familiar with your list of perfect squares, then you can use it as well. So for the rest of the problems that I'm going to do as examples here, I'm going to do them all the perfect square method. If you need to see them the other way, just let me know in class and I'll be glad to do a couple of them that way. Alright, so now I want to skip on over to, let's look at number 8 on that worksheet. It is the square root of 175. So I'm looking for a perfect square that will go into 175. Because this ends in a 5, it's got to be something on my list that ends in a 5. So I want to start with my perfect squares that are less than 175. So start here. The first one I get that will go into 175 is 25. And you can try them all. but this is the first one that will actually go into 175. So I'm going to rewrite 175 as 25 times 7, because 25 times 7 is 175. And now, remember, I told you I'm going to quit splitting it apart. I'm just going to go ahead and take the square root of 25. It is 5. I marked it out because I put it on the outside. I can't take the square root of 7. It stays inside. And that's your answer. All right, the next one I want to look at is number 12. It's a little bit different. Number 12, we have 9 times the square root of 245. So I need to find a perfect square that will go into 245. Okay, the first thing I would look at are the ones that end in a 5. Maybe 25 will go. Maybe not. I'm not sure it will this time, so maybe one of the others will. I want to start with all of my numbers that are smaller than 245. So I start here. 225 won't go, 196 won't go, 196 won't. I'm thinking maybe 9 might be the first one. So let's grab our calculator and divide that and see what is 245 divided by 9. Nope, that won't go. So this one, I'm struggling to find the perfect squares that are factors of 245. So I'm going to go to prime factors for it. Okay, and this is why you always need to know more than one method in case one is not working for you. So I'm going to take my 245 and do my factor ladder. Now, I want to start with my first prime number and try a 2. Well, 2 won't go into 245. My next prime number would be 3. 3 won't go into 245. So I'm going to go to 5. 5 goes into 245. It will go 49 times. I still can't use 2 or 3. Now I can't use 5. My next prime number is 7. So I've got my 9 on the outside. Inside, I'm going to write that as 5 times 7 times 7. Because on my factor ladder, all the numbers outside on the left and the one underneath are all prime. So we're done. Now I have a pair of 7s here. That pair of 7s gives me 49. The square root of 49 is 7. That goes outside with the 9 that was already there. And now the numbers that are outside get multiplied together. The 5 has to stay in because it didn't pair with anything, and that's your answer. Okay, so if you're trying to do the perfect square method and it's taking too long or taking, more time than you want to put into it, you can always do the factor ladder. Sometimes it's quicker. It just depends on the problem. So from time to time, I'll use both. Let's do one more. We'll pick one that's got some big numbers in it. Let's look at number 23. It is 11 times the square root of 1,215. Okay. So I'd really like to use perfect squares because I don't want to have to do a factor tree or a factor ladder for that number. So let me get my calculator up here, and I'm going to start dividing 1,215 by the list of perfect squares. So I'm going to start with 1,215 divided by, I'm going to start with 625. I don't think it'll go. No. So let's move on down. I'm going to drop down to 225. That won't go. I don't think 169 or 144 will. So I'm going to try 121. Nope. And then I'm going to try all of the ones from 84, not 84, 81 on down. So 1,215 divided by 81. It goes. So I can stop right there. So I'm going to come over here and rewrite 1,215 as 81 times 15. Now I can take the square root of 81. It gives me 9 that goes on the outside with the 11 that was already there. So now when I multiply the 9 times 11, I get 99 outside. The 15 won't break down. It doesn't have a perfect square that is a factor still in it. So it just stays in there, and you're done right there. Okay. So you need to work on practicing the rest of the sheet. Come back next time. Let me know if you have questions, because for the next few sections, you are going to have to be able to simplify square roots.